In this video, I skipped ahead just a bit in exercise number 1 to problem number 8. After I finish up with problem number 8, I'll also solve in this video problem number 10 for those that would like to see it. So problem 8 is a little bit different in that it goes against our general rule. Our general rule here in conducting conditional proof, again, is to assume the antecedent of the conclusion that we're asked to derive. But that's problematic here in problem number 8 because there is no antecedent in the conclusion to assume at all, as the conclusion we're asked to derive is just a single variable, in this case t. So we've got to scrap that rule and think about what would be in a useful assumption, given that we are in fact to use conditional proof for the problems here in exercise number 1. And unfortunately, when that rule fails you, there isn't a secondary rule here for you to rely upon. You're simply going to have to figure it out. So we'll resort to an old strategy here. Let's see if we can't spot the variable that we're asked to derive and the information that's given to us in these three premises. And nicely here for us, t only appears once as a part of the consequent of line number 2. So we've got to think about how we're going to get that t by itself. Well, given its location, the consequent, a part of the consequent anyway, of a horseshoe statement, what rule allows you to get out the consequent of a horseshoe statement? It's our very first rule, of course, modus ponens, but to do modus ponens, we need the antecedent to that horseshoe statement. So what we would like to have here is that entire antecedent. We would like to have p horseshoe r. Now obviously, if we could get p horseshoe r on some other line down the road, we could do a modus ponens, getting us s and t by itself. And once we've got that, the main operator would become the dot. We can do a con, switching the order of those variables, and then simplify, and there would be the t by itself. So this will, in this particular problem, be our guide for our assumption. We'd like to have p horseshoe r. So now we've got a horseshoe statement. Let's assume the antecedent to the horseshoe statement we would like to have. So in this case, our assumption will be p, indent for line 4, assume that p, ACP. And what can we do with the p? Well, immediately 1 and 4, modus ponens, and we get the consequent up there. We get q wedge r. What we want before we can discharge that conditional proof is the consequent to what we'd like to have. We need to keep going until we get the r by itself. So how are we going to get the r by itself? We now have lines 3 and 5 to work with, both of which contain an r. So how are we going to isolate the r? And that really, once we've taken on the proper assumption, once we realize we need to assume p, that becomes the trick to the problem. You'll notice here in reviewing our basic 18 rules, we don't have any rule that simultaneously works with both horseshoes and wedges. This will become a fairly common pattern. What can we do when we need to work with both a horseshoe and a wedge? Well, the thing to do, it seems, is to switch that wedge to a horseshoe, giving us two horseshoes to work with. An alternative strategy, perhaps, would be to switch the horseshoe to a wedge, setting up perhaps some sort of conjunction and distribution. So simply put, we're just going to have to think our way through the problem until we figure out the appropriate combination. So let's get these to where they're both the same logical operator. And to do that, obviously, we need to do material implication. But going from, if we're choosing to switch this to a horseshoe, going wedge to horseshoe, there needs to be a tilde to take away. So that would be my next step. I've got to introduce a couple of tildes into the picture, and of course the rule that allows me to do that is double negation. So 5dn, not q or r, this would allow me now for line number 7 to do 6 material implication, impl, wedge to horseshoe rather, wedge to horseshoe, take away tilde from the lead variable, leaving 1 behind, we would get not q horseshoe r. And now here we can't immediately do a hypothetical syllogism with 3, as we do have a couple of common variables, but things aren't aligned just as we would want them to be. So perhaps we can do now a transposition to align those two variables so that we can in fact do a hypothetical syllogism utilizing up here line number 3. So let's see what that would look like. 7 transposition, reverse and negate, we get a not r, horseshoe, not q, which turns out just to be q. And so as a result, and this is really the key step once we take the appropriate assumption, after having done double negation, impl, transposition, those again the key steps, we're ready for 3 and 8, finally hypothetical syllogism. For line number 9, there's the common variable. and we would get not R, horseshoe R. So we're close to getting the consequent of the horseshoe statement that we originally wanted. So what can we now do to line number 9? Well, if we convert it back to a wedge statement, we will have set up tautology. So horseshoe to wedge this time, 9 impl, horseshoe to wedge, you add a tilde, giving us 2 consecutive tildes in front of the first R, not R. So let me throw in a double negation there. Not R, of course, is R. R or R, well, that's redundant. 10 tautology, and we'll have R by itself. We're ready to discharge our conditional proof, and this is turning out to be a rather lengthy problem. We're ready to discharge conditional proof, linking the first line, our assumption, and the last line of that conditional proof together with a horseshoe. In this case, we get P horseshoe R. Justification consists of all of those lines, 4 through 11. And unlike some of the earlier problems, we're not done. We're done with our conditional proof, but of course, our line number 12 doesn't match up with the conclusion we're asked to derive. What we've been able to do, however, by finally getting line number 12 after the result of our conditional proof, what we've set up here finally is 2 and 12 mode exponents, a simple com and then a sim, and you'll have the T by itself. So I'll go ahead and let you finish that problem off by yourself while I move on to problem number 10. Problem number 10, 2 premises to work with, and the conclusion we're asked to derive is C or B, in parentheses there, horseshoe A. So this one's a little bit more complex than some of the problems that we've seen thus far, but there's no need to deviate from our general rule. Our general rule in conducting conditional proof is, again, assume the antecedent of the horseshoe statement you're asked to derive. So again, no need to deviate from that. We'll just simply assume the antecedent of the horseshoe statement we're asked to derive, even though it's complex. We can assume whatever we like. It'll turn out to be the antecedent when we discharge. So no need, again, to deviate from that rule. Assume the antecedent. Assume the whole thing. In this case, C wedge B. Assumption, conditional, proof. So don't let that throw you here. You can assume whatever you like, including something, in this case, that's complex. So what can we now do with C wedge B? Well, hopefully a pattern leaps right off of the page at you. We can begin to set up a constructive dilemma. In 1 and 2, we've got 2 horseshoes. And now in line 3, given our assumption, we've got the antecedent of each of those horseshoes joined by a wedge. So one of the necessary conditions to pull out constructive dilemma, I've seen this many times before, we need 2 horseshoes joined by a dot. We don't have that, but we do have 2 horseshoes. Easy enough to join them by a dot, 1 and 2 conjunction, which will involve introducing some brackets. Line 1, C horseshoe A and D, and line 2, B horseshoe A and E. Put in the brackets, clearly identifying that dot as the main operator there. And now 3 and 4, we've got our 2 horseshoes joined by a dot, we've got the antecedent of each, and line 3 joined by a wedge. 3 and 4, constructive dilemma, and we'll get out the consequent of each joined by a wedge. A and D, or A and E. So what can we do from there? Given, again, never lose sight of the end goal, we've assumed the antecedent of our conclusion, we're after the consequent. What can we do to line 5? Well, that's a fairly textbook case of distribution. This time sucking out instead of distributing, sucking out, to put it again crudely, sucking out that like variable, and no need to reorganize here. The like variable in each of the disjuncts is in fact the lead variable. So to 5 we can immediately do distribution, and we get A, leftover parts, D, E. Main operator starts as a wedge, flip it to a dot, use the wedge as a leftover, and we're real close to getting the A by itself after having done distribution. One easy step, 6 simp. Get the first conjunct by itself, which is our A. So we're now ready to discharge. We've gotten the consequent. We can now discharge, unindent, join the first line and the last line together via a horseshoe. In this case, C or B, horseshoe A. Need to introduce the parentheses, clearly identifying the horseshoe as the main operator, seal it off, and the justification 3 through 7, conditional proof.